I accidentally learned a swear word in a foreign language one time. And this is just the very beginning of my speech at the beginning of the day, so I'm not going to tell you what the swear word is. I don't want to start by cursing at you in the morning. But it sounded like in English just the word ow, like just some random collection of syllables that you might say when you stub your toe. And I was teaching in the country at the time where they speak this language. And I was in my classroom with my elementary school students, and I whacked my shin on the desk, and I said, ow. Only I didn't say ow. I said this other word. And my students all gasped and laughed and pointed at me, and the host teacher said, Laura, where did you learn such a word? And the thing is, I couldn't tell her, because that word just popped into my head and right out my mouth. Humans are so good at recognizing patterns that we can see that we pick these up without even making an effort. I'm going to make a change on my presenter display here because I'm mirroring, and that's not going to work for this. So all the apologies while I make the setup that I should have done a few minutes ago. All right, displays. I have a couple. I'm better at thinking of stories sometimes than I am at remembering them, and I want to make sure that I actually tell you the stories that I've thought of. Arrangement. Let's not mirror. Here we go. Beautiful. All right. Excellent. So this talk is called Reading in a New Language, and like many of you, I recently learned a new language, Swift. The last project that I worked on was one of the first to adopt Swift in a production code base. So I got a lot of experience with it really quickly. And it was, working with this new language, it was sometimes wonderful and sometimes kind of terrible. But it reminded me so much of my experience studying and teaching new human languages. Before I was a programmer, I was actually a very strong language enthusiast and language teacher, as you may have guessed from my story. And so I want to share my thoughts with you about fluency as it relates to code. We're going to talk about what readable code is, then why you would want to write it, and then once you're convinced that you should, we'll move on to how to write readable code. But first, I want you to believe me that programming really is a little like learning a new language. When you first start something in a programming language, you do something very simple. You print hello world, and it works. You feel like a genius. And similarly, maybe when you're learning a new human language, maybe you're attending a class to learn this language, and one day, after class, you go up to one of your classmates and you say, you and me, today after class, coffee? To which they reply, oh no, I'm sorry, I'm busy after class today. How do you feel about this? Amazing, because you asked if they could meet after class. They said they were busy after class. That means they understood you. This is amazing. And then eventually you progress on through the language a little bit, and you get to the intermediate phase. And in programming, this might be something like in iOS, you set up a table view and it displays some data, or you've stood up a server and it replied with something. It's not glamorous, but you probably felt like you were a genius when you first did it. It feels really good. And similarly, maybe in a human language, after a few weeks of studying in this class, you go up to a different classmate this time, ask them out for coffee. They say yes. You go out and you have this 10-minute conversation over lattes. And it's things like, how is the weather? And who is in your family? And maybe if you are feeling very confident with your past tense, what did you do last weekend? And it is the most boring conversation in the history of conversations. But again, you feel really good about this because you both understood each other for multiple sentences in a row. And then you get to the advanced phase, where now if you ask somebody out on a date, you're not thinking so much about whether they'll understand your language and whether you're using the correct grammatical tenses, but whether your hair looks okay. And on the way, maybe as you're walking to the coffee shop together, maybe you start talking about movies, and you understand each other, this is no problem, but then they say something that makes you pause. Like maybe they say, 3 Idiots, it's okay, I guess. You say, what? Like how could you think that movie is just okay? And you maybe pretend that you get an emergency text message and like, oh, I'm sorry, I have to go. And in code, this might look like you're interviewing a job candidate and things are going all right, but then they tell you that their favorite pattern for communicating within the app is just using notifications everywhere. They think this is a really good idea. And maybe you don't give them a chance to explain, and you just say, you know what, thank you very much for your time. It's been, we'll call you. As we develop fluency in human and programming languages both, we leave these basics behind and we start focusing on nuance and subtlety. Sometimes this subtle understanding can even work against us. Even when we understand someone perfectly and we agree with their meaning, the way they communicate their intention still can make us kind of want to throw things. And this is as a signal that you're holding on to a stereotype. For example, people in the US will sometimes say, I don't think Southerners in the United States are stupid or lazy. No. I just think the Southern accent sounds stupid and lazy. Really, have you ever held a belief about an accent or a language that did not in some way also mirror the stereotypes and biases that you have against that group? And these sorts of stereotypes and biases, they carry over to programming languages and communities too. We have, imagine someone seeing your code for the first time and saying to you, oh, you know what, you implemented this we'll make up a programming language, like you implemented this the way that a Zebra developer would. And do you feel a little angry and defensive? Like, oh, no, I don't have anything in common with Zebra developers. Let me tell you how I'm different. Or do you feel a little proud? Like, oh yeah, I guess I always have had kind of a little zebra inclination. And just imagine how your feelings about this will affect your willingness to learn from or adopt anything from that language community. Humans bring so many expectations to code. And sometimes these expectations, they really do work against us. For example, being fluent in a second human language can make it easier to pick up the basics in a third. It's less surprising to learn that there are genders of nouns in Hindi once you've learned that there are genders of nouns in French. But fluency in one language, it doesn't translate to fluency in another. In fact, it can make it harder to get to that point where something just sounds right. Because you know in this other context, like that would be a totally fine way to say it. For example, usually one of the first words that you learn in another language is thank you. And Americans, when we're being polite, we say thank you a lot. When I pay my bus fare, the bus driver says, oh, thank you. But in some languages, yes, there is a literal translation for the phrase thank you, but it has really a different meaning. It means more, wow, I appreciate your great effort that you went to. I am so grateful. And can you imagine if you pay your bus fare and the bus driver says, oh, I am very grateful to you for your effort. And this happens in code as well. Let's say in Swift you have some collection of costs and you decide that you want to do some transformation on it, to transform each of the costs. You can write this in Swift. This will compile, it will work, it's fine. It means what you wanted it to mean. Is you loop over everything, you create and build up an array piece by piece. But this isn't how a fluent Swift developer would implement this, is it? Swift actually removed the C-style for loops, for I equals 0, I plus plus. They removed those from the language to stop us from doing things like this. They want us to write a map. But that's not a requirement that the computer has. That's a requirement that we as humans have. We say, you don't look fluent. And when you change all of your habits to adopt to one environment, it's really hard to change them back to things that maybe used to be second nature. You know, in the US, we drive on the right. I spent some time, a couple months in a country one time where people drive on the left. And I was fine. I got used to it. I had no problem. And then I came back home, was crossing the street and almost got hit by a car because I was looking in the wrong direction. And if that's not a metaphor for switching programming languages, I don't know what is. But this switch is not a problem for computers. You say to computers, like, hey, I have some new parameters set up for you. This is the environment you need to work in now. Like, they don't say, like, but no, I remember the old one so well. I mean, yeah, there might be some caching stuff going on, but once they make the switch, it's fine. Computers execute code without really complaining too much most of the time. It's the humans around code who bring all of this baggage, all of these biases, all of these extracurricular requirements for our understanding of program source code. And most of us would say, yeah, without hesitation, that we would love to spend our days working with clear, readable code. I think it's not even uncommon to say, I would rather have code that's broken but understandable than code that's incomprehensible but somehow mysteriously works. But what does readable code even mean? I want to illustrate with a story. One time I witnessed a conversation between two developers about a code review. The first person said, could we change this pattern, please? I'm having trouble understanding it. To which the other replied, no, see, it's more readable this way. I'm just going to leave this up for a minute. The one person says, this is hard for me to read. But the other person says, but it's so easy to read. In English, you can describe something as readable or enjoyable without actually defining who or what is doing the reading or enjoying. If you ask somebody, hey, is LA an enjoyable city? They're not going to answer you. They're going to say, it depends, like for who, for what. And yet for reading, somehow with this code is readable, this pattern is clear, we imagine that this has meaning without specifying a reader. Now, there are as many opinions about what makes readable code as there are people in this room. This is the main source of trouble with making readable code. You have to consider your audience. And not only, though, do we all disagree on what readable code is, but even if we were writing for only one other person to read, we as developers still have two completely different audiences for our code. One is this human brain with eyeballs or a screen reader trying to make sense of what your code is doing, but this other is a computer that's running through your files and executing their instructions. And the computer often has really loud and strong opinions about whether it understands your code or not. And since the computer is so persnickety, it's so full of complaints, when it gets confused, as developers, we mostly orient ourselves to writing code for the computer. Have you ever fiddled with a line of code or a class just until it worked, and then you don't quite know why it works, but you take your hands off the keyboard and you kind of back away, vow to never touch it again? That is prioritizing the computer audience over the human one. I want to keep pushing on this human side of processing code, and I want to illustrate readability and what it is with part of a poem, actually. A couple lines from When Serpents Bargain for the Right to Squirm by E.E. Cummings. When serpents bargain for the right to squirm, and the sun strikes to gain a living wage, when thorns regard their roses with alarm and rainbows are insured against old age, then we'll believe in that incredible, unanimal mankind. And not until. I'll read it again. When serpents bargain for the right to squirm and the sun strikes to gain a living wage, when thorns regard their roses with alarm and rainbows are insured against old age, then we'll believe in that incredible, unanimal mankind, and not until. You may have understood many of these words, but what does this actually mean? There's something delightfully unsettling here. There's a meaning that slips away until we read and reread, and something shifts and the pattern falls out, and it's so satisfying when it resolves. And when it does, we look back on the original text and wonder how we ever failed to grasp it. Now, it took me, just so you know, about 10 times reading this poem before I started understanding it all, so don't worry if you are feeling puzzled. I wish we had enough time that you could also reread it 10 times, but I know that you came here to talk about code more than poetry. But although rereading a poem is wonderful and satisfying, I would argue that this kind of poetry, this kind that requires multiple careful readings to get that satisfying feeling of understanding a deeper beauty, has no place in production software. In production software, I want the sparse, immediate poetry of warning signs, where the more important and urgent the message, the quicker it is to understand. But although we nod at this, I promise you, we are each picturing a different implementation of what it looks like for code to be obviously clear, because readability depends on the reader. Now, part of the reason this is difficult is because we each have different strengths and different contexts. It's easiest to see maybe when you're first picking up a new human language. A nurse working in Florida in the US may pick up basic medical Spanish. A tourist in Martinique may learn to negotiate a price in French. I once spent a couple weeks in Jaipur, and I realized that I had learned most of my Hindi from Bollywood movies. So I could say to my taxi driver, "Teri aankhon mein ajab si adaye hai," which means there is a strange beauty in your eyes. But I didn't know how to say, "Stop the car, here is my hotel." And similarly in code, maybe using a factory class would seem obvious to someone from a Java background. If that's not where you're coming from, it may seem convoluted or bloated. Or maybe a bind seems like the most efficient way to express this relationship. But if your teammates don't understand these concepts, it will actually obscure your intentions. But even though we all have different levels of fluency, we actually all depend on the same skills to read. It turns out there's a strong tie between reading and working memory. Working memory is an extremely short-term store, very limited size, 5 to 7 things. It's the thing that lets you remember a phone number long enough to type it into a contact field on your phone and then forget it forever. Or, when you're first learning to read, it's the thing that lets you remember the letters that you've figured out at the beginning of the word long enough to make it all the way to the end. Now, working memory holds on to things for just about as long as you're using it, and once you direct your attention elsewhere, all that information starts to decay, which means that if you have 2 things in your head that you've understood, but you have to go look up the 3rd and the 4th, you're going to start to forget 1 and 2 before you have any chance of getting to 5. But you may be wondering, wait, I read things that are longer than 5 to 7 letters all the time. I'm pretty good at it, especially if I'm working with Apple. How does that work? We do this with a process that cognitive scientists call chunking. Chunking is when you take a bunch of primitive things, like letters, and you group them into a single thing, like a syllable or word, and then you just have to remember that group as one thing, and this gives you some of your 5 to 7 slots back. You may be thinking this sounds an awful lot like abstraction, and you would be right. So this is how we understand meaning from text, whether it's language or code. We start with pieces that we understand, build them up into more abstract pieces that we also understand. Eventually, you really grasp the problem. In code, we come across unfamiliar words or symbols all the time, right? There's functions whose purposes we aren't familiar with, variables that come from who knows where. And when we need to, we stop and we look them up in the docs or write in the source code one by one. And sometimes we end up in a bit of a rabbit hole because the definition or implementation causes more questions than it answered, but you keep researching until you find yourself back on solid ground. It's similar to the way a skilled linguist can decipher any passage in any language given a dictionary and grammar guide. It's with programmers, it's part of the job. With good tools and effort and time, we will decipher the meaning. But we're not talking today about the value of decipherable code. The only code that you truly can't decipher should be actual ciphers, code that is literally encrypted. Everything else, we expect that eventually we will be able to decipher. Deciphering and reading, though, they are not the same. Deciphering, this needing to stop and search in a reference guide every couple lines, you've done this, we've all done this, it takes huge amounts of energy. Most of us need special circumstances to be able to do it. We need quiet space, uninterrupted focus, none of this open office stuff. We need reasonable blood sugar levels, we can't be too hungry. I don't know about you, but as I get older, I need to have had a really good night's sleep in order to decipher code. Reading, though, reading happens when you can't stop yourself from understanding something. That's why people send images like this as a joke. If I ask you, hey, what color is that bottom line? You want to say red. I know you do, and you are wrong. Readable code is code that's quick to understand, like second nature. When you're guessing what it does, if you just look at it without thinking too hard, are you more likely to be right than wrong? So why would we want to write readable code? We may not like code that's hard to read. None of us like it. But isn't interpreting code just part of the job? I mean, yeah, some people do feel this way. And this attitude means that for some folks, admitting that you're having trouble understanding someone's code feels like you're admitting that you're having trouble even doing your job. So if you see a class that you have to puzzle over before you understand exactly what it's doing and why, it doesn't feel like a problem with the code. It feels like a problem with you, with your professionalism as a developer. It's kind of like if you've been studying a language for maybe a human language for maybe a year. You're trying to read an article in this language, and you go over it slowly. Eventually, you're looking things up. Eventually, you get the gist. And then a friend of yours who's been diligently studying for maybe 10 years looks at exactly the same article, skims it really quickly. They point out a grammar mistake. They smile at some wordplay. It's pretty clear that the difference in speed to understanding is related to your skill with the language. So to try to get a team full of people that understand code at maximum speed, some teams say they will only hire people who are fully fluent, no interns, domain experts only. But for those of you trying to hire developers, how many candidates do you get who can read and write code in your tech stack at a really expert level? Eh? And even if you find this person who surely exists, who knows all the syntax, all the libraries, and has agreed to join your team, the other engineers on your project are busy writing new code, which is effectively adding new vocabulary words to this language all the time. How can people possibly stay perfectly fluent in the vocabulary of a language that changes hour by hour? So, okay, you accepted. You can't hire a perfectly fluent person, fine. But you still come back and say, well, a skilled engineer, they'll figure it out. It doesn't matter the language. It doesn't matter the abstractions. They'll figure out the new stuff that we write. We don't have to try particularly hard to make it easy for them. But when code's easy to read for you, you can be lazily scanning through a class, and then part of your brain will sit up and say, hold the phone, that bit looks wrong. And then the thinking, deciding part of your brain kind of gets up off the couch and saunters over and takes a look and says, oh, yeah. This is never going to work asynchronously. We need to fix this. You don't have the mental resources, though, to do this, to decipher and reason about every class, about every line of code. You want to offload as much as you can to that snap judgment part of your teammates' brains, the part that just knows that in English, you don't ask a question with what you said. Like, wait, that's wrong. I don't know why it's wrong, but it's wrong. Hold on, we'll figure it out. No, you want to say, wait, what did you say? Paying close attention takes an enormous amount of energy and willpower, and those are finite. There's an often cited study that tests subjects' willpower with fresh-baked chocolate cookies or biscuits and radishes, a bitter root vegetable. Subjects are placed in a room in front of a bowl with one of these treats in it, either the biscuits or the radishes, and are told not to eat it for 15 minutes. And then at the end of this, the food is taken away, and the subjects are given a puzzle to solve. It's a maze. And they start working on it and working on it. Surprise, the maze is unsolvable. And it turns out the subjects who only had to resist eating radishes would struggle through this maze for 15 minutes on average before giving up or asking for help. The subjects who had to resist eating the chocolate biscuits would only work on it for maybe 8 minutes before giving up, and they were grumpy about it when they did. I remember one time sitting in the backseat of a friend's car. We just spent a weekend at the beach together, and my friends were French, and I majored in French. My French is fine. So we'd spent all weekend communicating in French with no problems at all. But on the way home, they were driving, I was in the back by myself, and the car was a little bit warm, and the conversation was just on the edge of my hearing in the front seat. So I actually just leaned back, and once I stopped paying attention, their words became just this wash of nonsensical sounds. It was very nice. French sounds beautiful, especially when you don't understand it. You've probably had this experience yourself in long code reviews, where maybe you start off really caring about this code review because they've made these sweeping changes to the data processing layer, and you want to make sure that they haven't introduced any subtle threading bugs. But about halfway through, your eyes kind of glaze over and your posture changes, and you start just going, oh, you know what? This pattern seems fine. Yeah, I recognize that method signature. Just whatever, ship it. And now, whoops, you've not just used up your willpower working on this code review and maybe not done a very good job on this code review, but you're going to have a harder time concentrating on the next task you have to do. So it's important to write code that your teammates can read, not just so they can fix all the bugs that you write, although that would be nice if they could easily do that, but so they don't drain all their energy doing it. So let's imagine that you believe me, yeah? That decipherable code is not enough, that we're really striving for readability, and to do that we're thinking hard about our readers. Even then, it can be hard to know what to do. You understand the code you wrote. How can you predict what will be easy or hard for a reader, maybe even someone you haven't met? We can actually take a clue from our interactions with non-native speakers of our language. We are used to changing our speech when we communicate to people who are using their second or third or fourth language. A lot of y'all have been doing this all conference. We can learn a lot from those behaviors when we think about code. For example, you stop using quite so many idioms and slang. Instead of "you rock my socks," wait, what? You're not even wearing socks. No, you say, "you are really great." In code, this might look like, instead of using in-joke sorts of names, "release the hounds." Like, what does that even mean? No, as straightforwardly as you can, begin app setup network requests. Another example, you'll enunciate clearly. Did you know that in the US, if someone says "jichet," it means "did you eat yet?" And similarly in code, enunciating clearly may mean that you stop using these abbreviations. Write out the whole thing. When I was using an audio processing library recently to make an app in Swift, and they keep talking about M-buffs and S-buffs, and okay, it's sample buffer and memory buffer, and I think there's a B-buff. It made it harder to understand what was going on for me as a beginner because they decided to make things more convenient for people who already knew the concepts. You'll also introduce regional dialects slowly. Y'all come back now. Like, oh, what, did I forget something? No, this means I hope you visit again. In code, this means you may decide to wait to introduce things like custom operators. Now, I'm not saying never use them, but think about non-native speakers of your programming language, about new people to your code base, and try to make a thing that they will actually understand. My favorite way to create readable code, though, is using patterns. So people can learn almost any pattern, right? English speakers, like, we learn that to make an umbrella plural, you add an S and it's umbrellas. Trousers is always plural. You would never say to somebody like, oh, that's a nice trouser you have there. No. But we learned the plural from woman to women, from children to children, child to children. Sheep becomes sheep. But we are so capable of developing this intuitive grasp of patterns that actually make no sense. But don't make us work this hard for your code, right? It's so much easier to group things together and chunk them for our working memory when things that act the same look the same. To show you a very small example in code, this code is pretty simple, right? It's setting up two variables, it's assigning strings to them. No one would say, oh, this code is hard to understand. But even so, this is actually kind of hard to scan effectively, because these are related variables, but you can't tell that just by looking at them. You have to read all the way from the beginning, good idea description, description of bad idea, to understand the relationship between the variables. But look how this way, your eyes just pick up on the different shapes when the beginnings all line up this way. And this is why people get excited about things like lining up the colons or the commas and method calls, because it pops out to your eye even more, to your pattern recognition. You can use this not just at the line level like this, but also at the file level and the function level. Have you heard of the Squint Test? When you squint at something, the Squint Test, you close your eyes almost all the way and you just look out through your eyelashes so the whole world is fuzzy. You can literally squint at code to try to see its structure without any of that pesky implementation getting in the way. I'm going to show you a file. This is fuzzy on purpose. You will not be able to read it. Don't worry if you can't see. That's the point. But you can look at this and decide right away which parts look similar. If you were going to refactor this, you could take a pretty good guess at what might be a reasonable chunk of code to pull out into its own named function. You don't even know what language this is, and you might already have opinions about that. So help us pattern match well. Just because we can learn to perceive a thing does not mean it's worth the mental overhead. So take your code that serves similar roles and make it look similar. This will help develop our intuition. And our tuition is the thing that will someday, allow us to understand your code without drawing down our energy. But which patterns to use? Well, it turns out this also depends really heavily on your teammates. How much does it depend on your teammates? I want to show you with another story. Une petite histoire. En automne, en septembre, un groupe de musiciens participe à un pique-nique. Ils s'amusent avec leurs instruments, le violon, la trompette, les cymbales, etc. Oh là! Soudainement, un monstre horrible arrive. Les musiciens sont terrifiés. Le monstre approche et applaudit. Il adore la musique. Quelle surprise! So did you follow that? Do you speak French? So I used to use this story when I taught beginning French to 10-year-olds. This was by far the longest story they had ever read in French. And I could tell that they understood it because they would start reading and they would get this goofy grin on their face. And then by the end, they would laugh at the punchline because this story is hilarious to 10-year-olds. But I could get away with this because I knew my kids. I knew that they knew English already. I knew that these words were all cognates, that they were the same in English and in French. And we used these cognates as context clues to even figure out the other words that they didn't know. It was great. I could have told this story using very different words. But it was my expertise in French and my expertise in my kids that allowed me to choose words that would not confuse them, that would not frustrate them, that would allow them to understand the meaning. So you have to somehow write code that's easier for someone to read and understand than it is for them to rip out and start over. And this is a surprisingly advanced skill, because what's clear for one person is going to be complete gibberish for another. You have to really know your team well to do it. Now, if you're interested in writing readable code, it means you also have to believe people when they say your code is not clear. Now, you believe in your heart your code is perfectly clear. You wrote it, you understand it, but someone just told you that they don't get it. And it's easy to ask rhetorical questions like this. What's wrong with them? Why can't they read this code? We think they're not trying hard enough, or maybe are just not smart enough. I catch myself thinking this at myself sometimes, which is uncomfortable and completely unproductive. But instead, the empathetic, non-rhetorical way to ask is more like, what information are they missing that's making it hard to read this code? This works both ways. Thinking about your teammates' background is going to help you write code that takes advantage of their particular experiences. And when you are personally confused by some code that you're reading, this question, what information am I missing? This is going to help you focus on what you need instead of how painful it is when you have some code that you don't understand. So that's some advice for how to write readable code. Be empathetic to your teammates' needs. Listen to them when they say they're having trouble understanding, but most importantly, be predictable. We are so good at recognizing patterns, but you've got to be consistent enough for us to do it. But let's be honest, it is not always feasible to write code that is geared towards the least fluent team member. I'm sorry for the long letter. I didn't have time to write a short one. This quote has been attributed to a number of different people. It's very clever, it's very true. It turns out writing simple, clear code is really difficult. And when you're under a deadline, it can take more time than you have. Sometimes it takes more skill than you have. It is hard to write for these two simultaneous audiences, the computer and your teammates both. Which brings us to our final question. When? When do you work hard to make something readable? And when is it okay instead to just require that your teammates draw down their energy to understand this code? The folks who landed the Mars rover have a coding guideline that I love. Code shouldn't be arguably, but obviously correct in the most important parts of your app. Now, to me, the mark of a really senior developer is that they can not only write code that their team understands, but they know when it matters. They know when to push back on other developers in a code review and say, hey, this works, but it needs cleaning up. You need to put in some more consistent patterns, maybe some better encapsulated chunks of sections that you give names to, because when we have to update it, this is going to be really hard to fix. I worked on an app one time with an engineering manager who had been a brilliant coder but hadn't done coding in a little while and was not at all familiar with iOS. Wrote an Easter egg for our iOS app. It was just some little animations to do something fun, to surprise people when they took a particular action. And I looked at this code and said, oh my gosh, I don't know how this works. But you know what? It does work, and if the Easter egg breaks, the consequences aren't very big. If we have to update it, it's worst case, we will just take it out. It's fine. So yeah, we shipped it as is. But something maybe related to the persistence of user data. This is not the time to play with some patterns that you picked up from Haskell that no one on your team understands. If you put code that your teammates can't easily read in these mission-critical parts of your app, it's like leaving piles of boxes and obstacles in a fire escape, right? Even if your fire escape is at an Olympic track and field training gym, and you know that the athletes will be able to physically jump over and around these obstacles, you don't want them to have to when they're fleeing a fire. And remember, again, because readability requires a reader, mission-critical code needs to be obviously correct, not just to you, you genius writer, but to the majority of the people on your team. So as you become more senior, as you grow in your career as a person who creates software, there's a few ways that thinking about readability will help move you along. First, as a developer, you can start by just noticing. Notice whether the code you're writing follows the norms of your particular code base. Notice whether your particular code base follows the norms of the community at large. You don't have to change anything right away. You don't have to insist that everything that is different gets refactored, but just practice that muscle of noticing. Because if you can clearly explain why a particular piece of code is confusing, you are halfway to being able to intelligibly write it yourself. And if you're in a position where you decide what tasks the team tackles next, and some team members are telling you, you know what, this one file or this one section, it's a really big problem in our code base. Nobody understands it. Maybe the development team is begging you to be allowed to refactor it. I mean, you know, you can ask them to just try harder and figure it out. That may be your judgment and your responsibility as a team lead. But understand that your team spending effort to make sense of this code here means that they have less energy for the next task. Is it worth it? It takes wisdom and experience to decide where the efforts of your team can be best applied. Listen to your team, believe them, believe their data about how much energy they're spending deciphering. And teams, this is a really good chance to practice that skill of explaining very precisely why you are confused. Now, there's no easy solution to writing code that everybody can understand, right? We don't even know how to eliminate misunderstandings between native speakers of the same language, speakers who have 10, 20, 50, 80 years of practice becoming fluent. Writing readable code is a hard problem, and it is not going away. It's hard, but it matters, because if as a team we decide to give our pattern matching abilities a boost and use empathy to figure out what's working for different team members, we'll develop better fluency in this code base, so we all spend less time deciphering and more time reading. So we have energy left over, and so we have energy left over so we can write and build and create. Thank you.